Hello, this is a video to demonstrate and explain a register with left shift capability. I copied this off existing registers and my CPU over here, so it has this RD capability that I may not need. The purpose of a left shift register, for my purposes, will probably be to try to build a multiplier circuit. So this is the first step. I need to be able to shift left and right to build a simple multiplier circuit using shift and add principle. Okay, so this register has a read pin for reading from the data bus, a write pin for writing to the data bus. Here's my data bus pins. Here's my RD pins, which are just always reading from the D latch. And here's a left shift pin. The basic design of a single bit, just on the register side of things. The data comes in off the data line, and I can I'm either using it to write a D latch value here on that D latch, or I can read from the D latch using the read signal using this relay. It is designed for a sort of continuous write signal. That's my instructions and my CPU. They'll just activate write, and that write signal will be on until that instruction stop execute. But for the left shift, I actually use a one tick pulse. I run it into a one tick pulse. Okay. So to do the shifting, all I do is when I write a value to these D latches in the register, I also make a copy, but I shift the copy. So this D latch here gets copied here, this D latch here gets copied here, which is just simply a matter of connecting the output here. Well, actually, it's going to be the input to this D latch during the write. So here it comes through here, through this through peg to the other side, down this wire here, inputting into this D latch here. And then I connect the enable signal coming in off the right line just straight across here. So when this thing gets written, this thing gets written. But this is a shifted copy. And the least significant bit is just 0, so I don't have a D latch there. Hopefully that part is clear. So the only tricky part then is what to do when the left shift pin goes on. Then I want to copy the shifted bits to the register D latches. So I run two lines. One line, the one on the left here, is coming from the one tick pulse. So left shift input to the one tick pulse down this line, and this is a one tick delay of that. So coming to, say, let's just look at this one here, this bit. The one tick pulse off the left shift comes in here, enables this read register, and reads this value from the shifted bit. And then the data from here comes to the, let's see here. Yeah, the data comes through the read down here up this wire into the input of the register's D latch. Now I need to pulse a write signal as well, and that is delayed because it takes one tick for the read relay to turn on. So that's the purpose of this one tick delay. And then that signal just comes into the enable pin. All right, so I could show this in operation here. Let me just first show how the copy works. So I'll turn that on. I'll do a write. I'll turn off the write. I'll turn off that. And then we can actually see the copy here. It copied from here to here. Okay, so now when I activate left shift via this switch, it will shift to the left. And let me just make this slightly more interesting just to show it doesn't just work for one bit. It'll left shift all these bits. And there we go. And if I shift again, this bit here will just get lost. It doesn't get stored anywhere. And that's it. That's all there is to see here, I think. Hopefully this was some help to anyone thinking about creating a shiftable register. Thanks for watching.